Hello everyone, welcome to this channel. Today we are going to see a very simple yet a very interesting topic, that is the limit, fits and tolerance. Okay, so let us first discuss about limits. So what is limits? For example, we are going to design any mechanical component, for example a shaft or a hole. Okay, so we know that we are human beings, so it is not possible to manufacture exactly the actual size. For example, we need to make a shaft whose diameter is 20 mm, but that is not possible. So for that purpose we set a limit. That means maximum we can give it, or we can make it 20.02 mm, and minimum we have to make it 19.99 mm or cm, whatever it is. So here, for the actual size, or for the basic size of 20, maximum limit or the upper limit is 0.02 and the minimum limit is 0.01, that is in the negative side, minus. So it is a minimum value, it is a maximum value. So in between this two limits we have to manufacture our shaft or the product. Okay, so this is called limit, this is called upper limit, that is the maximum value or the upper value, and this is called the lower limit or the minimum value, right? Suppose if somebody asks you the definition, you will say the two extreme permissible size between which the actual size is contained are called limits. Okay, so these are the two extreme permissible size. In between this we have to manufacture our product. Okay, I think it is clear. Now what is limits can be of two types, that is one is the unilateral limit and another one is the bilateral limits. That means here we have considered one positive and one negative, right? But if the case is like that we have to make suppose 10 is the basic size here, and the upper limit is plus 0.02 and the lower limit is plus 0.01. So this is known as unilateral, where both the upper limit and the lower limit are positive, or maybe 0, one may be 0, one may be positive, right? This can also be negative. So this is also known as the suppose it is upper limit is 0.00 and the lower limit is 0.0 minus 0.02, right? So these are all the unilateral limits where the sign is not changing. Okay, the plus or minus, it is having no sign, right? So point from 0 to minus 0.02, that means the sign is not changing. This is known as unilateral limit. But in bilateral case there is a sign change from plus 0.01 to minus 0.01, from plus 0.03 to minus 0.02. So this is known as the limit. Okay, I think the concept of limit is clear to you. Now we will move into the tolerance part. So what is tolerance? In simple language we can say difference between the maximum and the minimum dimension of the permissible error. Okay, so whatever we have learned about limit, the difference between the limits is known as the tolerance. Okay, just now we have said that the upper limit can be 20.02 and the lower limit can be 19.99. okay, so the difference between the upper limit and the lower limit is known as the tolerance, right? So here for example 21 is our basic size and the upper limit is plus 0.02 and the lower limit is minus 0.02. so 0.02 minus and minus of 0.02, that is the tolerance. Okay, so upper limit is becoming 21.02 and the lower limit is 20.98. so the difference between these two is 0.04. so we can say that 0.04 is our tolerance. Okay, that is the maximum range. We have to just subtract the upper limit and the lower limit. Clear? Now we will move into fit. Okay, so what is fit? In mechanical equipments or the components, we can say that any two parts, okay, any two parts, for example there is a hole and a shaft, these two part will meet or will have a fit like this. Okay, that means the shaft will move inside the hole. We all know that this is a male part, shaft is the male part and the hole is the female part. So the male part will be getting inserted into the female part. So this is the procedure of a fit. Now the question is that how this mating will happen. Will it be very loose or will it be very tight? So we can define fit into three categories, or we can categorize it in three parts. One is the clearance fit, one is the interference fit and the transition fit. So what is the clearance fit? If for example this is a shaft and we are taking two limits of a shaft, one is the lower limit, one is the upper limit. Limits we have already seen. Now we are taking hole. So hole is of the bigger size because the lower limit of the hole is greater here, and there is the upper limit of hole also. See, if the upper limit of the shaft is even smaller than the lower limit of the hole, that means the shaft is getting inserted very easily. Okay, no restriction or no difficulty in entering into the hole. So this kind of fit is known as the clearance fit, where the lower limit of the hole is even bigger than the upper limit of shaft. So we can also call it as a loose fit. Okay, so this is known as the clearance fit. Now what is interference fit? That means it is very difficult to insert if the upper limit of the hole is smaller than the lower limit of the shaft. So at no condition it will be inserted. Okay, only we have to apply some force, or we have to heat this component, and we have to make the hole in bigger size. Then when it shrinks, the shaft may move inside. Okay, so by the application of heat or force we have to make this fit. Okay, so where the lower limit of the shaft is greater than the upper limit of the hole, so this is known as the interference fit. Okay, now what is the transition fit? Transition fit is the we can say is in between this clearance fit and the interference fit. Means the tolerance overlap each other, right? I think it is clear to you that transition fit can be sometimes behave like a clearance fit and can sometimes behave like a interference fit. Okay, so the tolerance of the both hole and the shaft is overlapping like this way. Okay, so this is the transition fit. So I think the whole concept of limits, fits and tolerance is clear to you. Even if you are having any problem, so you can comment in the comment section and ask your doubt. I will try to rectify it or solve it in the next video. Okay, so thank you.